Industry skills, practical knowledge, real-world impact. This is Simple Gyan.
Every time you switch on a light, charge your phone, start a machine, or run an air conditioner, you are touching one of the largest engineering systems ever built by humans, the electrical power grid. It is so reliable that we often forget it exists, but behind that simple switch is a massive network of generators, transformers, transmission lines, substations, and control rooms. For more than 100 years, the electric grid worked mostly in one direction. Power was generated in large stations, transmitted, and finally delivered to homes and factories. But the world has changed. Today, electricity demand is rising because of electric vehicles. Data centers and clean energy technologies, solar and wind power are growing fast. This is why the old grid must evolve into something smarter. A smart grid is an electrical grid combined with sensors, communication networks, and artificial intelligence. In simple words, the traditional grid delivers electricity. The smart grid understands electricity. The story begins in the late 19th century. On September 4th, 1882, Thomas Edison's Pearl Street station in New York started generating electricity. But Edison's early system used direct current, or DC. DC was useful, but it had one major limitation. It was difficult to transmit over long distances efficiently. Customers had to be close to the station. Then came the great battle of electrical history, the War of the Currents. On one side was Edison's DC. On the other were Nikola Tesla and George Westinghouse, who promoted AC. AC had one powerful advantage. Voltage could be stepped up for long-distance transmission. In 1896, AC from Niagara Falls proved electricity could travel long distances. That was the birth of the modern power grid. The traditional grid was built like a highway, but the future grid is more like the internet. Millions of devices sending and receiving energy and data at the same time. Renewable energy is variable. Solar falls when clouds come. Wind changes with weather. A smart grid is not one machine. It is a complete ecosystem, starting with smart generation. The grid must balance generation and demand instantly. Even a small frequency deviation indicates imbalance. Transmission is the backbone. High voltage reduces losses because losses are proportional to current squared. Smart grids use phasor measurement units, or PMUs. Think of it as high-speed video versus a single photograph. Distribution is where electricity reaches you. Smart systems use feeder automation and smart meters. One powerful function is FLISR. It detects a fault, isolates it, and restores service automatically. This is a self-healing grid. India is pushing large-scale smart metering, with provisions for 25 crore prepaid smart meters across the country. A smart grid works like a nervous system. Sensors are nerves. Communication is the spinal cord, and the control center is the brain. Solar output falls as the sun sets, but demand rises. The smart grid manages this transition in real time. Electric vehicles aren't just loads, they are batteries on wheels. With smart charging, they can help the grid. Microgrids can operate independently during a failure. The grid becomes a network of intelligent energy cells. Artificial intelligence predicts faults before they happen. This changes maintenance from reactive to predictive. But digital grids must be protected. Cybersecurity is as essential as electrical engineering in the modern grid. Smart grids reduce losses, improve billing, and delay expensive infrastructure upgrades, saving billions. India's RDSS program is a major step. Technology alone isn't enough. Correct implementation makes a grid smart. In the future, homes will generate power, buildings will be flexible, and AI will forecast every problem. Instead of a breakdown, problems become managed conditions. That is the power of visibility and automation. The smart grid delivers intelligence with electricity. Smarter power is the future of our civilization.